Hello, everybody. Today, we will be finishing up the review for the compound interest module, and it's really not so bad. So I think that this module, the test, will be happy. It's not really bad at all, I don't think. I expected the questions to get this is somewhat ugly, as they sometimes do, but these weren't bad at all. So I was happy to see that. So let's begin that. And I'm going to need my trusty old calculator. Let's see if that's up here already. If not, it will be shortly. There we go. And then here we go. We're still setting a really good pace in here. You can see that this test isn't really due to November 20th because of the online students who are starting later. And then we only have 3 more modules. So I guess it could even end up, well, looking when they're due. I don't know, we might finish up a little bit early, but that just gives you extra time in case you didn't take some of these tests. And please take them all. If you take all your tests and I have all your grades to work with, that gives me some room to be more generous on grades. But if you don't take them and you just got a bunch of zeros, there's nothing I can do about that. That's too tough. So make sure you at least everything. And you do have till, I think the last test is due like the 11th. So we have time. And actually plenty of time. It's not even November yet. Another month and a half. So stay at it. If you're just joining us as an online student, just start with the first module. Watch the videos, especially the ones of us working through the practice questions, which are very similar to the test questions, and all the discussion that takes place during those Zooms. And then text me along the way. And I'm very happy to help. You could pass a certain question. And don't lose, don't run out of gas. That the modules don't get harder as they go along. So just because you run into a really hard one doesn't mean the next one's going to be worse. Sometimes they get easier, and they do. As a matter of fact, I think the hardest one so far has been, I think, the markup one, module 3. And then module 4 was easier, and module 5 is not bad either. So anyway, we're going to do 9 through 15 on the compound interest practice quiz. And it's going to reference those tables again. And I'm going to do what I did last time and do it on a calculator because the tables are old and outdated. And I mean, calculator is not that modern technology. We should be able to move that far forward.
Did you ever get time to do the questions from the test?
Oh, I had plenty of time to forget it. What do you remember which one it was?
I don't remember exactly. I think it was 20.
I have it written down somewhere. Let me look. I think Bahia sent that to me first, and I think I
do have it, just looking for, I think it's 22, 22 and 24.
Yeah, I got your text, and I even starred it or whatever, so it stayed at the top of my text.
Okay.
But I haven't done it, and I apologize. But I will get to it. I'm sorry, it's 22 and 24. So just hold off on those two. We can still move forward, but I'll work those two out and do it. I'm sorry about that, but I'll get them done here before too long. Thanks for reminding me.
Welcome.
All right. Number 9. This narrative thing, you see them reference? Those are the tables. And the tables are posted in Canvas, but we did 1 or 2 with the tables. There's no need to make life difficult for yourself. We'll just use our calculators. And we have a formula that we pretty much stick to. I'm going to write it down here at the top. The amount with interest for compound is equal to the principal you first invested or borrowed times 1 plus the rate divided by the number of periods during a year. So if you're compounding monthly, that would be 12 periods per year. If you're compounding semi-annually, that would be twice. So that's what n is. And then you raise it to the power of n times t, which is the total periods. So n is the number of periods per year, and t is the number of years. So if you were compounding quarterly for 10 years, that's 4 times a year for 10 years. That would be 40 periods, 4 times 10. So your exponent would be 40. So that's all that is. So it looks worse than it is. But anyway, this one's a little bit different, but it uses the same formula, the annual percentage yield. And if you've taken out a loan and bought a car or a house in the last, 10 or more years, they have to list the annual percentage yield. The government makes them list it. Nobody ever reads it or knows what it is. So it's kind of pointless, but after today, you'll know what it is. What it does is show the compounding effect. Now, 8% simple interest is just 8% once a year. Most of us can understand that easily. But when you start compounding it, you're paying interest on interest. So the effective simple interest rate of a compound interest is higher. And that's what they're talking about here, annual percentage yield. So all we have to do is find the total interest. We're going to use our compound formula, find the interest we paid, and then take that dollar amount and divide it by the principal as if it was simple interest and see what percentage it comes out to. So if you're paying 8% interest, but it's being compounded, the effective, or what do they call it, annual percentage yield is going to be a little higher than that, a little higher than 8%, because the compounding makes you pay interest on interest, and that's what pushes it up. But you'll see. And we're going to calculate using the formula we do, we're going to calculate our amount with interest. Then we're going to figure out how much of that is interest. And then we're going to divide that by the original principal amount. So our formula is going to be amount equals principal times 1 plus the interest rate, which is 8%. Compounded quarterly. So how many times is that per year?
It's 4 times.
Very good. Thank you. And then the exponent is the number of times per year times the number of years. Well, 4 times per year for one year, 4 times 1 is 4. So flip over to our trusty calculator and we get 7,000 1 plus 0.08 divided by 4 raised to the 4th power. So the total amount, principal and interest, at the end of the loan is 7577.03. So that's the total amount. Now we need just the interest. So we'll take that total amount, 7577.03. I rounded up to the nearest penny. And we subtract the original principal, and that'll tell us how much interest we paid. So of that total amount, 577.03 was the interest. And then looking at that as if it was simple interest, if it just happened once per year, like simple interest does, you take that, you take that total interest amount and just divide it by the principal that you borrowed. And you can see that 8% under the conditions, the compounding conditions that we were paying, is a little more than 8% as simple interest. It's 8.24%. So hopefully that's an answer. And there she is right there. So that's all that's asking us to do. Now see if you can do that on this next one. $5,500. I'll write this down. I can always say, see if you can do it. And then I start to do it. Can't help myself. I love to work math problems. So this is your principal. 1 plus, oops, forgot the 1. 1 plus the interest. And it's compounded monthly. So that's 12 times per year. Let me fix my plus sign. I don't like that. Now, for 1 year. So if you're compounding 12 times for 1 year, that's 12 total times. All right, so that gets you started. That'll give you the amount, which is the $5,500 plus interest. Do that, find how much of that is interest, then divide by the original principal amount. See what you get.
I got 5,839.23.
All right, let's see. 5,839.
Yes,
And how many cents?
23 cents.
Okay. So we take that. We say, how much of that is just interest? So we subtract off the principal and we get 339.23. So that is the amount of interest we paid after a year. Now we want to know what interest rate would have that been if it was just simple interest. Well, the way we find that is to take that interest, and I'll need you to do this because I don't have my calculator open, and we divide that by the original amount we borrowed. And it should give us something a little higher than 6%. Oops. What do you get when you do that?
I got 0.6. Yeah, 0.6. No,
Give me-
0.06, sorry.
All right, give me a couple more decimal places.
0.061678.
All right, so we'll round it to that. Because there it is. Good job, Heath.
I got a question. Why did you divide the number?
Because they ask, that's just how we do this thing when they ask for annual percentage yield.
Oh, okay.
Annual percentage yield is figuring out the interest you pay in a year and then dividing by the original principal. You say, I took out a loan and it was 6% interest, but I paid at the end of the year, I paid more than 6%. And you did because it compounded. So they say, well, what percentage, if it was just simple interest, what percentage would that have been without the compounding? So that amount of interest we paid, if it was looked at as simple interest over the year, would have been 6.17%.
Gotcha.
And that's the thing, they disclose that on the paperwork for buying it when I buy a car or whatever. I don't even look at it. I mean, I don't know what it's supposed to, some congressperson saw a way to get votes and try to be the hero of the common man because we're too stupid to think for ourselves and required more paperwork. And here, it's some of it's just ridiculous. I just laugh when I think about if I buy, this is Southside Virginia, so I've bought a little rental house before that cost like $35,000. It was cheap, but it wasn't wrecked. And stacks of paperwork to buy a $35,000 house and expect closing costs, thousands of dollars of closing costs, stacks of paperwork. I could walk into a car dealership if my credit's okay, and they would take a copy of my driver's license, and 2 hours later I'd drive that car home. It's ridiculous what they've done to home mortgages and made the process so onerous. They're like, oh, we need to make home ownership easier. Well, step one, get out of it, quit interfering so much in it. All the regulation, it makes it so hard to do. It's absolutely ridiculous. Inspections and all this kind of stuff, and they say, well, we want to make sure you're going to pay your loan. We want to make sure the house is in good condition. Well, I mean, nothing depreciates faster than a car. I buy a $35,000 car and drive it off the lot. It's probably worth $28,000 the next day. So, I get annoyed by that kind of stuff. It's hard for me to believe the motivation is really to help us in the end. It's just a gathering up votes. Anyway, there's my little rant for today. My little percentage rate rant. Anyway. let's try the next one. And good job, everybody, doing that. All right, well, this one's just asking for the compound interest. So this is even easier. All we have to do is plug it in our formula. And then, which gives us the total amount we paid, principal plus interest. And then we subtract off the principal and see how much of that was interest. So we do that. I don't know why I wrote it again. It's right up there. $8,000 we're borrowing. 1 plus 6% compounded semi-annually. So that's twice per year for 1 year. So we have 2 periods per year and only 1 year. So 2 times 1 is 2. So let me flip on over here. I love this calculator. I just put everything in just like I write it down. I don't have to do anything weird. And it looks just like it looks when I write it down. All right, there is the amount, which is the original interest plus the principal. So 84.87 is what the total we ended up paying, including the interest. The amount we borrowed was 8,000. So the amount of interest we paid, 487.20. I'll let you get that down, and then we'll see if that's one of the answers. There it is. Nice. All right, Antonio invests $3,000, 10%, compounded semi-annually for 12 years. Use the formula to calculate the compound amount for this investment. So this one's even easier because our formula gives us the compound amount. So no subtraction or anything at the end. We're just going to figure this out. So let me not ruin it. Let me let you try that from the beginning. Semi-annually, so think about how many times per year that is, and then 12 years. So then think about how many total how many total periods that is, twice a year. Oops, I just gave that away, times 12 years. And put that in the formula and let's see what you get.
I got 9,675.30.
For some reason, I feel like I'm not setting this one up properly, so I might need to see how this is done.
Yeah, I don't know if the exponent is 24 or another number. I put 24 times 2 and 12. I don't know if that's
Okay, yeah, I think I didn't do what you did, so you're probably right.
Sorry, I stepped away for a second. I heard you all talking, but I think I heard you figure it out too. Let's see, the principal is 3,000. 1 plus our rate is 10%. And how many times per year? 2. Okay, and now the exponent is the number of times per year times the number of years. So I think I heard somebody say that 24.
yeah, that's what I did.
Yeah, very good.
Okay, yeah, I think I was going wrong with the 2. That's where I put
It's
24.
easy to
instead.
do. Yeah.
Yeah.
The exponent is n times t, the number of times per year times the number of years. Sometimes it gets pretty big. And when it gets big like that, it pushes it off those stupid tables too. They don't go up so high. So that's another reason not to use them. But anyway, what did that come out with? Come out to?
I got 9,675.30.
All right. Anybody verify that? It looks good to me. Well, it was more. I know that seems high because you only borrowed 3,000, but it was 10% interest. That adds up quickly.
Oh, yeah.
And you had it for 12 years.
Right.
So when you borrow somebody's money for 12 years, it's going to cost you more than 10%. You know, we've had this really a record run. And for some of you young people, most of your adult life of low interest rates. And it's been very easy to borrow and interest rates were very low, but they're going up quickly now. And this is what big interest rates do. And part of the reason they have to do that is that slows down spending to slow down inflation. So, you know, if it costs us that much to borrow, what do? We don't borrow so much. We put off that new car or that house or something we were going to borrow, wait for better times. And that slows down how fast money is moving around because we're not spending anymore as fast as we did. And when you slow down spending, that helps put inflation back in check. But unfortunately, and that eventually unwinds everything, but it usually means several years of suffering because then when people quit spending as much, you know, I go out to eat less, I buy less, people start losing their jobs. People who make those things that I'm not buying anymore and work in those restaurants where I'm not going anymore, they start to lose their jobs. So unemployment goes up and that's unfortunate. But anyway, that's what's happening now. Question 13. $18,000. Oh, here's the one where it switches up on us a little bit. Same formula, but now they give us everything but the P, and they want us to solve for the P. Before, they gave us everything solving for A. Now, they're going to give us A and ask us, what is P? And we can do that. It takes one extra little division step, so we can do it. See, now we want to end up with 18,000. So that's the amount we want to end up with. So that's our A in that formula. And they want to know if we want to end up with 18,000, what principal do we put in at the beginning of all this? So that becomes the unknown, the principal. And then this stuff is all the same, 1 plus. And this is like if you were planning to buy something, you're like, I need to save 18,000. In this case, for 1 year from now, I want to have $18,000. How much can I, if I know I can get 10% on a certain investment and it's compounded semi-annually, how much should I invest under those conditions to end up with $18,000? So that's the use for this. 10%. Semi-annually, so that's twice a year. And only for 1 year. So 2 times per year for 1 year, exponent is that. Now that may look really ugly, but all we really have to do is figure out this number here. I didn't do a very good job with my circle. Let me try a square. Figure out that. Then we divide that 18,000 by whatever that number is in that box. And that tells us what P is. So if you would, or we can do it together, we're going to calculate that. One plus that 10% divided by 2, parenthesis, raised to the second power. So that's what we get. And so it's P times 1 point. Is that what you got? P times 1.1025. So back in our, if we remember our algebra days here, we may not want to remember them. If we have 18,000 equal to P times 1.1025. The way we get P by itself is to divide by 1.1025 on both sides. Because over here it cancels out. Magic. 1.1025. And that'll leave us with what P is equal to. So we'll take that 18,000 that we want to end up with, and we divide it by 1.1025. And that tells me that if I want to end up at the end of the year with $18,000, under those conditions, I would start by investing $16,326.53. So if I invest that under those conditions, which is 10% compounded semi-annually, then I'll end up with $18,000. And I'm going to guess that's one of the answers. That one right there. Wow, 2 problems left. Let's see, so 14.
Mhm.
Same type of problem, different numbers. Let me let you get a start on it first.
No. Mon garçon.
All righty. We are looking for our principal. We want to end up with $19,000. That's our amount. So that times some principal equals 1 plus 8%. How many times per year?
4, I think.
Yeah, very good. Quarterly, so that's 4. Now, if you got 4 periods per year and 12 years, what's my exponent going to be?
144. That'll,
Close. 4 times per year.
oh,
So 4 times 12.
so 48 then.
Yeah, very good. Yeah, if it was every month, then that would be 12 times per year in 12 years. That would be 12 times 12, 144.
Oh, yeah,
But in this case, it's just 4 times per year.
right.
All right, so we got to figure out
Dead mouse.
this number. Let me do that.
$49,154.30.
That sounds a little high. Did you get this for what's in the blue box?
Oh, I times it by the, okay, I see what it is.
Yeah, we're going to divide it into that number. I think you probably did it right, but you times it times 19,000.
Yeah,
The next step is to divide it into 19,000.
okay.
So you probably had all the right numbers and just the wrong button on the calculator. There we go. 2.58707. How many more digits do I need? Not many. Anyway, there's a bunch of digits. So if I invested $7,344.21 under these terms, then 12 years later, I would have $19,000.
Mhm.
All right, see if that's one of the answers. What was it, 73.44? Is that it right there? That might be a few pennies off because they said use the tables, and the tables are not as accurate. But is that close to what we had?
Yeah.
344. Yeah, so I'm going to declare that the answer. There we go. And one more. Same type of problem. So see, it didn't get much worse. I think this is one of those tests where you might look over the video a little bit, but I wouldn't take too long to do it because I think it's fresh now and not terribly difficult. You could probably knock it out pretty quickly and be done with it. Move on. Let's see. I want to have $14,000 this time. So I want to figure out what principal I'm going to have to invest. 1 plus, see my interest rate, 6%. Compounded semi-annually, so that's twice a year for 13 years.
13.
So 13 years and twice a year, what's my exponent going to be?
26.
Yeah, very good. 26, 2 times 13. Nice. So I calculate that little thing next to the P. The little thing, that's not a real very good mathematical term, is it? 0.06 divided by 2. Raised to the 26th power.
Right.
All right, so that's that number. And then that's the number we divide into the 14,000.
Right.
And I'm going to just put in a bunch of decimal places since it's right there. I can see it. It's easy. 5, 6, 5, 9, 1, 2, 6, whatever. All right, I get $6,491.70 some cents. 64.91, 70 something. There it is. It's a nickel off. We'll let them slide. But there you go. So compound interest, luckily, really just one formula to deal with. And just be careful. I know it's all arithmetic, all calculator work, but it's tedious. So you have to be careful. You get one number in the wrong place, the button messes it all up. So just work carefully through the steps for these problems, and you shouldn't have any problem. And remember, you could take the test twice. You don't have to take it all at one time. Do a few problems here and a few problems there. It's not due anytime soon, but I think if you do it before too long, those of you who have been here in class with me, I think it'll be a lot easier to do it before too long since we just went over it. I'll get this posted hopefully towards the end of the week. And between now and then, feel free to text me.
Okay.
All right. So thanks for coming again, everybody. I enjoyed talking to you.
Thank you so much.
Thank you.
I'll see you next week.
All right. Have a
Bye,
good
everybody.